Hi, my name is Lana Hudson and welcome to my Lab 5 presentation, Choose Your Own Adventure. So for Lab 5, I decided to apply Newton's second law to an observation of motion in the real world, particularly investigating the motion of a golfer's club with a non-zero net force using two modes. The objectives of my lab were to obtain real data from a video showing the motion of a golfer swinging a golf club, research standard values related to the problem but weren't given by the video itself, such as the man's height, the club's weight, etc., use physics principles to predict the club's motion, model the motion with Tracker and VPython, and then calculate values. The tools I used were Tracker and GlowScript Visual Python to produce a computational model of the object's motion. And in the end, the results of my lab came to show the computational model did give a fairly accurate prediction, but did not factor in air resistance in one account, which would account for the difference in observed and computational data. The significance of this lab is that it shows there are multiple forces acting on an object, and using weight and drag force, possibly predicting a motion, makes it a lot more accurate because those forces do actually exist in the real world. The fundamental principles that I used in this lab were Newton's second law applied to the real world, which we're familiar with from previous labs, used to update the velocity equation and the position equation of the golf club in the coding, as well as gravity and drag being the air resistance force mentioned in the previous slide, weight force being F gravity, which is negative mgf, and drag force Fd equaling negative b magnitude of v squared times F. In the picture on the right, you can see the gravitational force law application showing the force of gravity on the second object by the first, and then on the further right of the picture, you can see the gravitational constant, 6.7 times 10 to the negative 11, which is factored into that force law equation. So now to the tracker analysis. So for the tracker analysis, we observed the motion of the golf club. We positioned the axis at the center of the bottom of the club, and then we created a position y versus time graph. The main takeaway from the tracker analysis was that the graph produced a nonlinear graph, and this showed that the forces present on the golf club were non-zero at all. Fnet was not zero, and so the ball was not moving at a constant velocity. The measurements gained from the tracker analysis were the mass and the man height, which I did research and approximately put at 5 feet 9 inches, which is the average height of a man, given that he's crouching a little bit, and came to be 0.305 meters. And the observations taken from the tracker analysis were the start time, the initial velocity given the club at rest, and the initial position given the club at the origin, as well as the end time. Moving on to the GlowScript analysis with no drag as a factor, as you can see in this coding, we began as the ball being the golf club and then Fnet eating the weight force. Weight in this case is the force generated by the gravitational attraction of the Earth on the golf club, which we mentioned a couple of slides before with the negative mg. We also updated the ball velocity and position using Newton's second law at the bottom of the blue box in the middle screenshot. For the next GlowScript analysis, you can see the Fnet now equals weight force plus drag force. Weight force, again, being the gravitational attraction of the Earth on things like airplanes, or in this case, the golf club, forgive that. And then the drag being the aerodynamic force that opposes an aircraft's motion through the air, or in this case, the golf club's motion. We also updated the velocity and position using Newton's second law at the bottom of the blue box in the second screenshot as well. Now we took all of these things and we compared them. I took a slice from the data, given so many data points, but I plotted all 3 of the ones from Tracker and then the 2 from the computational datasets in VPython, and this graph on the right was the given comparison. As you can see, the computational data that factored in the drag was a lot more like the observed data. The golf club was in fact experiencing air resistance, and the model without drag did not factor this in, and that is why there is a huge difference. The tracker being in the highlighted green, the no drag being in the turquoise, and the drag being in the blue. So in conclusion, we did a couple of things. We observed the golf club in motion. We modeled with Tracker and GlowScript, the tracker with drag and without drag. We compared all the data, and then talking about error analysis, we can say that there was probably human error in recording the tracker data, and so this would account for some of the discrepancies in the final results. So, and again, I used the what does it mean from lab 2 because it says a lot about this lab as well. And so in determining the terminal velocity, what does the model say? Well, the terminal velocity be seen a lot with the computational model because it factors in the drag force, which you can see in the explanation on the left. And then secondly, imagining the object was thrown downward. So if you took the golf club and you just swung it downward, would the terminal velocity in this case be the same or different? They would be a lot more negative in a further distance in the time interval. Because the terminal velocity will be reached a lot quicker. Again, these results are a lot like Lab 2, and so I decided to use the what if and what does it mean to just show the comparison and how they're very much alike. Thank you so much.